This is 1993, number 19. What is an odd function? This is kind of mind-blowing for some of you. An odd function, suppose you had a point here, we'll call that a, b. An odd function is going to have a point opposite of the origin on the other side. That's what you need for an odd. So there's going to be a point over here, and that's going to be opposite A, opposite B. Because obviously your A is on the opposite side, and your B is opposite. So that's the conditions to get an odd function. Now next, what is that saying? So suppose you have, this is odd, suppose you have f of x. Well, for the odd function, you plug in the opposite of x. So now you put opposite of x in for x. What should that result in? It should result in a number that's opposite of the original. The original was b. You should get the opposite of that. So that should be the opposite of f of x. Hopefully that makes sense. So when you get f of x, if you plug in the opposite of a, your b should be opposite. So if you plug in the opposite, you should get the opposite y value. That is craziness. Now let's do this. In our particular example, what's f of x for x being positive? So for positive values, it is x. So that equals x. What's f of opposite of x? That means you're plugging in a negative, x is negative, you're going to get x cubed. So according to this, when I plug in the opposite, I should get the same y value, but negative that. Is that the opposite of that? No, because that's a cubed and that's not. To be the opposite, this would have to be like negative x cubed. Now they're opposites. So that isn't even, oh, I'm sorry, I lied to you. It's minus x cubed. So if I put in a minus x because I have a negative x value, I put a minus x. These are not opposites of each other because there's no cube there. So therefore, not odd. Not odd. Okay, is it discontinuous? Well, what does this function look like? I'm smart enough to figure that out. Y equals x, that's a straight line. Like that. X cubed to the left, I know what x cubed looks like. X cubed looks like this. There is my function. So, is it continuous at 0? Yes. There's no jumps, holes, or gaps. Oh, is it discontinuous? No, that's false. So that's false. This is false. It is continuous, so it's not discontinuous. There is no holes. There's no gaps. Is there a relative maximum? Do you see a relative maximum anywhere? No. Is the derivative 0 at 0? Is the derivative 0 there? No. It's a sharp point. Look, curve, also in a straight line. The derivative does not exist at 0. There's a sharp point. False. The derivative is always positive. That would mean f is always increasing. Is that true? Yeah, this is always increasing. So the correct answer would be E.